Okay. Hi, everyone. It's on. Yeah. Hi, I'm Jakob Nordin. I'm from Berlin, which probably means that I will have a harder time getting home than all of you flying out of here on Friday or Thursday. We'll see how that works. So I'm going to talk. Now it's already going ahead. That's in a slideshow. So thanks to Francesco for very well demonstrated our current idea of a broker in the landscape of LSST alerts. So I am not going to talk about that, but all of that is true. Instead, I decided to steal minutes from the AMPEL presentation to talk about lessons from the Zwicky Transient Facility. Before that, I should point out that AMPEL is also a work of many people. Some are listed here. It's probably not a complete list. So lessons from ZTF, as you know, some of you were very involved. It was in many aspects similar to LSST, and we were not prepared when it started for what would happen. I think that the main misunderstanding was that we were waiting for the first alerts to arrive, and then once the alerts would arrive, we would just start doing science just like we had before. And that was not the case. What actually happened that there was a flood of alerts coming, and we kind of fought very hard to understand this river of data coming. And then we made some set of initial filters, and then eventually we could start doing science. And then it's kind of a question, what happened then? One of the things that did not work very well for CTF was that for a lot of science projects, developments a little bit stalled after this initial flurry of activity. At the other hand, the ZTF projects that really worked well, and there have been quite a lot of them, they were proactive and ID focused, meaning that they started with some idea of what could be out there in the universe, and then they tried to predict, make some sort of model, so how could that look? And then they went out and looked for that very actively in the data. So not waiting for the data to come from them, but really having an ID and then deriving their tools they need to find that in the data. So the example I'm showing here is for the search for tidal disruption events. Before ZTF, there were not many known, but there were a group of people that, based on the knowledge then, designed models for how to look for TDs, implemented them, and then very systematically found candidates and then followed them up with spectroscopic programs. And this was very successful, going from small samples to large samples now that we can subcategorize and so on. And similarly, there were programs doing multi-messenger science. So that was where I was mostly involved. So combining that with ice cube neutrinos. And then we could eventually associate these two programs where some of the extragalactic neutrinos might have been caused by TDs. So these were proactive programs, both of them. They also actively worked with the data during many years. So I think for a lot of the ZTF programs, we are still 6 years afterwards, after the start, learning how to actually better use the data. So this idea that the data stream would just come and then we would do science and kind of forget about this initial part is certainly not true. And LSST will, of course, run for much longer. So we need to build sustainable projects in different ways. One is just manpower. So 10 years vastly extends beyond the range of a normal PhD. It also ranges beyond the normal timeline of software projects as they're usually used in scientific areas. And they're typically also way beyond the range when we considered, for example, ESO proposals. So I think all of these things need to be considered. And we should really see this as a learning phase where we gradually grow better. And I think this ties a little bit back to Francesco's point about data-driven usage of follow-up resources, if I skipped that already. I think in the beginning, actually effectively using ESO resources would be to have a data-driven exploration of the data set that we're getting, such that we can actually understand the data and then design even better programs later. Another aspect is that provenance and fair actually has become important for a scientific application. So we have used these terms in proposals for a number of years. There has been a lot of products that claim to be fair compatible and so on. But now it actually becomes important for scientific studies for real, because we have a long, very large archive of variable data. And when we now try to understand this, it does become important. Who took what data? Why was some piece of data not taken, and so forth. And I think one aspect which is also of relevance when we talk about brokers and eventually LSST data products is that this aspect will directly connect the real-time alerts that are distributed with the data releases that will be coming later. So talking to a lot of future LSST users, you often find a divide. Some people, maybe multi-messenger users, they are going to use the alerts. They want to trigger things in real time. And then you have other people looking for variable objects that are saying, I'm not going to do any hard TO triggers. I can use the data releases. I can use the archives, and it's fine. What we're now finding in ZTF is that these two aspects merge. So when you're reacting on real-time alerts, you need to understand the archives, because that's where you have the full understanding of variability. When you're understanding the archives, for example, to do cosmology, you actually need to understand what happened on the alert basis, because that was the decisions that decided which subset was actually targeted in follow-up observations. So I think this distinction will eventually be fuzzy, and that's also something to keep in mind already now. And the final point about multi-messenger decisions. So we are working with a lot of multi-messenger streams, and every time we were combining all of these streams, and they will continue in number, we make irreversible decisions about which points can at all be coupled together, and which should we react to and which not. And these irreversible decisions we need to take into account and somehow scientifically include in the decisions that we're doing. Okay, so these were some musings based on ZTF. I think LSST will be exciting. I think we have learned a lot from ZTF, and I think we can do, if we design this evolving long-term products, I think we will do even better. Okay, so I will now switch to AMPEL. This is the most compact one-sentence description of AMPEL I could think of. So it's an analysis and workflow framework for high-throughput time domain astronomy. So broker does not enter per se. I won't talk about any technical details of how that actually works. I'm very happy to do so, so please find me later if you want to. Instead, again, coming back to the real topic, how to connect to alerts, I'm going to mention 3 ways of doing that here. So one is, if the one thing you're interested in is young extragalactic transients. So this is what most of the AMPEL users are doing. They're coming from the supernova community. So we have an infant supernova program that basically searches for potentially young extragalactic transients for immediate follow-up. And this program will continue into the LSST. This will be a very small set, a few candidates each night that can be easily visually inspected. And these will then be made available on the AMPEL webpage, but also on other front ends that you can access. So they will be there, and you can in some sense access them without knowing anything else. A second way to interact corresponds to what we might actually mean with the term brokering. So that's selecting properties of the full stream that you're interested in. So now we get back to this question of classification. So we will also host a general purpose classifier built on, in this case, a combination of an encoder decoder and boosted decision trees. So we have found no ways to beat the boosted decision trees. So these are actually still blinded outcomes of the ELAsTiCC survey that I hope that Gautam will say more about. But it actually works surprisingly well. So this is for the blinded validation sample. So we have minutes within, or replies within a few minutes, and then classification precisions that might range from 40 to 90 something percent, depending on which class you're interested in. I don't expect you to actually read any numbers here. You can go have a look at it if you want to. So what you will be able to do here is to select your favorite class, take some minimal probability level together with maybe the minimal brightness and the age of the transient that you want to have. The last two metrics will, of course, affect how good your metric is. Then you can get this stream delivered from a broker to your Slack account or your folder somewhere, or to one of the other front ends that are available out there. There's a list of them. So this will be available. Again, you can go to the webpage and find it out. The final way to interact with AMPEL is to actually design your own workflow. So I said a little while ago that it's not actually a broker, was not developed as such, but as an engine to run analysis on real-time data. So the two previous access points I discussed are all based on public workflows. You can find the links there, and you can actually install AMPEL locally and try and run these and extract the same conclusions we do. You, of course, can't run it on a full alert stream that you have to do on a computer center, but it can be uploaded to one and run there. To do so, you need to understand some of the internals of how to run AMPEL, which is work, but then you can actually eventually design your own workflow, which is when you really access the full power. For example, you might have your own classifier for your own particular kind of pet object. Then you can add that. Or you might have a better general classifier and beat everyone else. Then you can add that as well. Or you might want to combine these different data streams, maybe something only you have access to. Or you might trigger VLT rapid response mode right away, because I'm sure we will all have lots and lots of rapid response mode time to do this. So there is a live instance running at DESY Zeuthen where you can then upload this workflow for live execution. This is just for repeating later. Based on this, you can, these instructions, you can run a workflow and look for CTF optical counterparts to one of the LIGO triggers of last fall. Spoiler alert, you won't find any kilanovae, but you can do the search. This is the link to the web page. The different numbers correspond to different ways to access the data. So a summary. This will be a very exciting and challenging decade of real-time exploration. It is more a marathon than a sprint, and in actively working, I think the brokers will develop, the science teams will develop, and I think that will be fun and hard. So AMPEL is a framework for scientific computing. You can tune a stream for your scientific goal, or you can produce workflows. In any case, start talking to us and the broker teams. Start planning and trying out your workflows and your IDs. Thank you.